This is a little simulated creature I'm teaching to move and eventually to use a camera on its head to find a ball. But I'm not training it by hand. The whole research project is being run by a team of agents inside Claude Code. One of them plans the experiments, one runs them, one writes down what we learned, and one checks all of it against the theory we're testing. In this video, I'll show you exactly how I set that team up and the mistake I made that almost made the whole thing pointless. So why have a team of agents at all? The work itself is this. I'm using reinforcement learning to teach a little creature called Alien Baby how to exist in an environment like ours. This means the project runs as a loop. I decide what experiment to try, run the training, look at the results, and ask whether the results actually mean what we hoped. Then decide what to try next. As they say, rinse and repeat. You just keep going. When I first started, I did all of that in one long Claude Code conversation, and it works for a while. But here's the problem. A single conversation accumulates everything. Every file it read, every training log, every dead end. The context window fills up, the model's attention gets spread thin, and this is the real killer for a research project. I lose track of what we actually learned 3 or 4 experiments ago. It's too much information. So the fix in Claude Code is called a subagent. A subagent is a separate, specialized helper with its own job, its own tools, and even its own choice of model. The main session hands a focused task to a subagent. The subagent goes off and does it in isolation, and the main session gets back just a clean summary, not the whole mess. So instead of one overloaded generalist, I built specialists. Let me introduce them. Each of these is just a Markdown file living in a folder called .claude/agents, which that means it's a hidden folder, but there's a way that you can see a hidden folder in the Finder. I'm on a Mac, of course. The top of the file, the part between the dashes, is the configuration, the agent's name. And the tool below that is the agent's instructions. Basically, it's job description. First, the experiment strategist. This is the planner. Its only job is to read the project history and propose exactly one next experiment, what to run, why it's the right next step, what success looks like and what failure looks like, and how long it'll take. Then it stops and waits for me to approve. I run this one on Opus, the most capable model, because this is the job that needs real judgment. Second, the training engineer. This one's the hands. It takes the exact command the strategist proposed after I've approved it and runs it, but before it touches anything, it does a kind of a pre-flight check. Is the environment set up? Does the script exist? Is there a checkpoint? Is there disk space? By the script, it's, does it understand what it's supposed to do? Like the ball will go a certain distance or in a certain direction, and so will Alien Baby, that kind of thing. Then it launches the run and watches the log live. It runs on Sonnet. That's fast and cheap because this is execution, not really judgment. Third, the results analyst. This is the project's memory. After a run finishes, it reads the logs, pulls out the key numbers, and writes a plain English summary into a file called findings.md. Its single most important rule is never skip writing it down. That's how I stop forgetting what we learned. And this also runs on Sonnet. And fourth, the theory monitor. This is the team's scientific conscience. I'm not just trying to make the numbers go up. I'm testing 2 specific ideas about how learning should work. So after every run, this agent checks the results against those 2 frameworks and tells me whether reality is confirming to the theory or contradicting it. It can read and write, but importantly, it can't run any code. It only comments. I started with 4 agents that I set up, and I realized after a while that I needed a 5th. And that one is the literature scout. What happened was that I kept saying to Claude from time to time, has this been done before? Are we reinventing the wheel? How can nobody have done this already? And it gave inconclusive answers. So finally I thought, well, why don't I assign this responsibility to an agent? And that's where I came up with this literature scout. Go find out what else has been done. And it often runs before everything else. There's just one thing I want to point out, one or two things about this other agent. You don't want it going out and making stuff up. So the first rule that you see up top is that every claim about prior work needs a title, a year, and a URL that can be opened. No unsourced assertions, no it is well known that whatever. And we want to distinguish what is claimed from what is demonstrated. And these are kind of trying to shape the agent's personality in a way. Be a skeptic, not a hype machine. Nobody seems to have done this. Our valuable answers don't just invent stuff or kind of sugarcoat things. And then the rest of it has to do with being as thorough as you can. And also communicating well using plain English. Now, there are 4 design choices in here that I think are the actual lesson of this video, so let me call them out. 1, separation of concerns. Every single one of these files explicitly says you do not do X. That's someone else's job. You tell it what you want it to do and what you don't want it to do. The strategist can't run code. The engineer can't decide what to run. The analyst can't propose experiments. That's what keeps the system sane over a long project. 2, the right model for the right job. I've mentioned this already. Opus only where I need judgment, the strategist. Sonnet everywhere else. That's a real cost decision, not just a technical one. 3, scoped tools. The theory monitor literally cannot execute anything because it has no reason to. Permissions match the role. 4, built-in observability. Every agent announces itself when it starts and states who it's handing off to when it finishes. Here we can see some of the back and forth among the agents. The theorist has identified a core problem and now is suggesting an approach. It's asking me, the human in the loop, if I want the strategist to formally propose a particular experiment. I said, not yet. Then I said, do we have footage of AB, Alien Baby? The reason for that is that I really began to see that because Claude does not have vision, meaning it cannot really see video, it can't really see what's going on. So I'm telling it, the alien baby is moving its head so fast that it would cause a human to explode. Now, maybe I exaggerated a little bit there, but we should slow down its head movements so that, at least to this human viewer, it looks like the ball is in its visual field for more than a millisecond. Meaning, if you're trying to train this thing to go and touch something, and its head is flying around like a crazy person, I mean, really like some kind of an animal that isn't human, it's going to have a lot of trouble picking up the ball or knowing what to do. And I think this is one of the things that we need to do, which is to apply human perception and requirements to what we're seeing if the language model itself cannot see it. Okay, this is the part I actually love. What you're looking at is the whole team running live at the same time, each one in its own pane. On the top left is the strategist. The bottom left, the theory monitor, theorist as it's labeled. Top right, the results analyst. And bottom right, the training engineer. And here's the thing to notice. These aren't 4 tabs of one conversation. Each pane is its own separate Claude Code session with its own context and its own model. Look at the footers. The strategist is running on Opus. That's the one that needs judgment. And the workers are all on Sonnet. That's the right model for the right job idea. Except now you can actually see it. Now, they're not just sitting in separate boxes ignoring each other. Watch the names. Every agent is talking to a team lead. Results analyst standing by waiting for a message from the team lead. Training engineer handing off to the results analyst. They coordinate. One quick footnote, because there are actually 2 ways to build this. The first is a single orchestrator session that quietly delegates each job to a subagent in the background and gets a summary back. That's what I described earlier. It's clean, but you don't see much. The other way is this. Every subagent running as its own live agent in its own pane coordinating out loud through a team lead. Same agents, either way, they're all defined in those .claude/agents files that we looked at earlier. I went with the pains because I wanted to watch the team think. For a long project and for this video, being able to see the work happen in real time is worth it. I want to draw your attention to the bottom right training engineer pane. I told the training engineer to launch a run. It tried and immediately hit a wall. The Python environment didn't have PyTorch installed, so the training script died on the very first import. This illustrates the value of setting up those agents with strict do or do not instructions. Instead of trying to fix it quietly or silently fail, it followed its instructions. It diagnosed the exact cause and said, I am stopping immediately and not retrying. The environment needs to be fixed before the run can proceed. It laid out 3 possible fixes for me to choose from and handed the baton back. It refused to pretend a broken run was a real one. That's the whole reason I built it this way. A scoped agent that knows its job and knows when to stop instead of burning 2 hours of compute on a corpse, essentially, is worth it. Plan, run, record, make a judgment. And every one of them has that ability. That right there is the system earning its keep. I should also add that the Literature Scout came later. We'll take a look at some of its findings in upcoming episodes. I hope this has been a valuable introduction to turning Claude into a research team and why it makes sense to do so. Thanks for watching.